Good morning, everybody. So today we're going to talk about relations and functions. Okay, so we're going to first talk about what a relation is. A relation between two variables, x and y, is a set of ordered pairs. The x values are the inputs or the domain, and the y values are the outputs or the range. So here we have a set of numbers, a set of ordered pairs. The domain, here's the x values. Now it's 0. There's 2 zeros and 2 3s and a 4. You don't need to repeat the zeros. So the domain would just be 0, 3, and 4. The range would be -2, 2, -1, 1, and 0. Okay. So that's what we have down here. The domain is the set 0, 3, 4. And here's the range. Okay. So here's some other ways that we can set up a relation and show a relation. You can make a graph. Okay. So this is the domain is the x's. The domain is wherever you have an x value that has an answer as a y value. Okay. So the domain here would be 0, 3, and 4. The range is the y value. Okay. So the range would be 2, -2, 1, -1, and 0. Okay, we can also do this with a mapping diagram. So 0 goes to both -2 and +2, 3 goes to -1 and +1, 4 goes to 0. Or we can do it with a simple table. Okay, all of those are ways that you can represent a relation. Okay, now we can also write an equation. Y squared equals 4 minus x, where x is 0, 3, or 4. Okay, so if I plug in 0 for x, I get 4. So y squared is 4, and then y would be plus or minus 2. If I plug in 3, 4 minus 3 would be 1. I square root y squared, would be y squared would equal 1. So y would equal plus or minus 1. And if I plug in 4, I get 4 minus 4 is 0, so y squared is 0. And if I square root that, it's just 0. Okay, so every time I plug in one of these numbers, I get these numbers down here. Okay, a function. A relation becomes a function of x if every value of x has exactly one y value. Okay, so that gets a little confusing for people. Sometimes they get that backwards. The easiest way to do it is to use the vertical line test. The vertical line test says that if you can draw a vertical line anywhere you like on the graph and it only crosses the points of the graph in one place, it's a function. So like here, I draw a vertical line. It passes through the graph once, twice. That is not a function. Okay, if I take this vertical line and I pass it through all the points on the graph, it will only ever cross through one y value at a time, and so this would be a function. So not a function because of this. It's got two y values. This only ever has one y value for each x, so it is a function. Okay, so this fails the vertical line test. This one passes the vertical line test. Okay, so we can also do that here. Okay, here every x has exactly one y. Now it's okay to do this where they both go to the same y, but every x has exactly one y. So this is a function. This one, the 0 is okay, it goes to 0, but 9 goes to plus or minus 3s. So since it has two y's, it's not a function. Determine if the relation below is a function. Okay, so here's what we need to do. 0 goes to -5, but it also goes to +5. So this right here, I don't have to look any farther. That is not a function because 0 has two different y values. And it turns out 3 also has two different y values. So does 4. Okay, so this is definitely not a function. Okay. Functions are often described by equations. So for example, y equals 4x minus 3, and it's written as this is read f of x equals 4x minus 3. Okay, that's called function notation. And the reason that you write f of x instead of y is that if I want to know, say, what is f of 2? Okay, that just means that I take that equation and I plug 2 in for x, and that becomes 8 minus 3, which is 5. So f of 2 is 5. Okay, so there would be my answer. You read this as f of x, or the value of f at x. All right, let's evaluate the function f of x equals negative x squared minus 3x plus 5 at the given values. Okay, now you got to be really careful here, because see this negative right here? This is not, you got to remember this. Negative x squared is not equal to negative x squared like that. Okay, those are not the same thing. This will be a negative number because you square the x and then you put a negative on the front. This will be a positive number because you square the negative number. Negative times a negative is a positive. Okay, so be really careful of that. All right, so let's look here. F of negative 1 is going to be negative 1 squared minus 3 times negative 1 plus 5. Okay, so this will equal negative 1 plus 3 plus 5, which is going to be 7. Okay. So now we can find f of 4. I'll tell you what, why don't you pause the video real quick and do that one, and then jump back on and see if you got the same answer I did. Okay, so we're going to go ahead and take 4 and put it in here. So it's going to look like that. I don't know what's going on there. Let's redo this. Okay, negative 4 squared minus 3 times 4 plus 5. Okay, so that's going to be negative 16 minus 12 plus 5, which is negative 28 plus 5 would be negative 23. Okay. So here we go. That's the end of our lesson. We've got a little assignment attached to the end of this thing here, just a couple of pages. Yeah, just 2. So give that assignment a look, and I will see you later. Thanks.